Every single second, billions, no, quadrillions of invisible messages are flying all around the globe. They are the absolute lifeblood of our digital world. Today, we're going to decode the secret language that makes all of that possible.
I mean, really think about it for a second. You send a photo to a friend, and in a blink, it's on a screen halfway across the planet. How does that happen? It's not magic, not at all. It's an incredibly clever process that gets our data ready for what should be an impossible journey.
So, to get our heads around this journey, we've got to start with the basics. We need to meet the two fundamental types of messengers or signals that carry all our information. On one side, you've got analog, and on the other, its incredibly powerful cousin, digital. Okay, when you picture it, the difference is actually super simple. An analog signal is kind of like a ramp. It's smooth, it's continuous, and it can be any value along its path. But a digital signal, that's more like a staircase. It moves in these distinct, separate steps. And for what we're talking about, it only uses two steps, a 0 and a 1. That's it. And you know what? These two languages are literally everywhere. The sound of your voice is pure analog, just a smooth, continuous wave moving through the air. But the computer you're on right now, your phone, maybe even your watch, they all think and speak in the super precise, blocky language of digital.
Okay, so we've got these signals, our digital ones and zeros. But here's the thing, there's a massive problem. On their own, they're like trying to whisper in a hurricane. They just can't go the distance.
And that's the heart of the problem, right there. The low-frequency signals that actually have our information, our voice, our photo, our text message, they're just weak. Trying to send one across the country, forget about across an ocean, would be totally impossible. It would just fade away into static. But, engineers, they love a good problem. And of course, they came up with an absolutely brilliant solution. It's a trick that gives our weak little message a kind of superpower to travel the entire globe. And it's called modulation. The best way to think about it is like this. Modulation is like putting a letter on a high-speed train. Our message, that's the letter. It's got all the important information, but it can't get very far by itself. The carrier wave, that's the train. It's powerful, it's fast, and it is built for the long haul. Modulation is just the simple act of putting that letter on that train. So the recipe for this is actually pretty straightforward. First, you have your message, the actual ones and zeros. Next, you generate a really powerful but totally plain carrier wave. Think of it as a blank canvas. Then you use your message to stamp an imprint onto that carrier, changing it in a very specific coded way. The result is a brand new super signal, one that's carrying the unique fingerprint of your data. Okay, now we get to the really cool part. Because when you're dealing with digital data, our ones and zeros, this whole process becomes a kind of secret code. I mean, how do you actually embed a 1 or a 0 onto a powerful wave? Well, you do it by changing the wave's most basic properties. See, every single wave has 3 basic things you can mess with. Its height, which we call amplitude, its speed, which we call frequency, and its rhythm, which we call phase. Digital modulation is basically a secret code that gives meaning to tiny changes in these 3 things. Let's go ahead and crack the first one. All right, our first technique is called amplitude shift keying, or ASK for short. And this one is probably the most intuitive. It's all about power, or height. The rule here is dead simple. To send a 1, you crank up the wave's amplitude. You make it tall and powerful. To send a 0, you drop the amplitude way down low, or maybe even turn it off completely. It's basically a digital version of shouting to send a 1 and whispering to send a 0.
Okay, but what if we don't touch the power at all? What if, instead, we just mess with the speed? Well, that's our next technique, frequency shift keying, or FSK.
For this code, a 1 is like this really fast, kind of frantic, high-frequency wave that's oscillating super quickly. A 0, on the other hand, is a much slower, lazier-looking wave. The receiver on the other end just has to listen for the pitch of the signal, a high pitch for a 1 and the low pitch for a 0. And now for the third one. And honestly, this one is maybe the cleverest of them all. It's called phase shift keying, or PSK. And it completely ignores height and speed. Instead, it focuses on rhythm. I want you to imagine a carrier wave that's marching along to this perfect, steady beat. Boom, boom, boom. To send a 0, you do nothing. You just let that perfect beat continue.
But to send a 1, you intentionally make the wave miss a step. You create a sudden shift in its pattern. The receiver is specifically designed to spot that one little disruption, that skipped beat, and the second it sees it, it knows a 1 has just arrived. So, ASK, FSK, and PSK. I know it sounds super technical, right? But believe me, these aren't just letters in a textbook. These 3 secret codes literally build the modern world around us.
So where is this secret code? Well, it's literally everywhere. It's the reason your Wi-Fi works. It is the engine inside 5G mobile communication. It's what allows for crystal clear digital TV, life-saving radar systems, and secure military comms. Basically, anytime information is flying through the air to get to you, it's speaking in the language of modulation.
So why did this digital way of doing things completely take over? Because it fixes all the old problems of the analog world. It lets us cram a ridiculous amount of data onto the airwaves. It's incredibly tough against noise and static. And, maybe most importantly, you can encrypt it. It gives us everything we demand from our modern tech: capacity, clarity, and security. So the next time you tap send on a message, just remember what's actually happening under the hood. You're not just sending words. You are commanding a simple wave, maybe miles away, to suddenly change its height or its speed or its rhythm. You are speaking a secret universal code. We've built this entire world by sending a single 1 or a single 0 at a time. So the real question is, what kind of world will we build when we can send 1,000 of them at once?